for folks here who are interested in that as well.
Sure, thanks, Adam. Yeah, so hi everyone. My name is Wayne Dunstan, and you can probably tell originally from Australia, but I moved over here in 1999 to pursue a PhD at UCSD in the Mechanical and Aerospace Engineering department. So spent through 2004 doing my PhD on nonlinear system identification of resonant systems. And one of the things I guess maybe a common thought is where does a PhD take you? Do you keep going into an academic role or industry? And what are the opportunities out there in industry? And so I should say currently my role is I work at a company. The company's name is ASML, and it's based in the Netherlands as the head office. And we're in the semiconductor industry. And I am a program manager in that. We make a product which is called a lithographic scanner, and so that lithographic scanner is used to make silicon chips. So all phones and things, everything with a chip, TVs, every chip in the world, basically gets made with our machine at the different customers. So Samsung, Intel are the big chip makers in the world. Taiwan Semiconductor, and so they make chips using our machines, and I run programs, building products for our company. So that's where I sort of ended up, and I got there after my PhD by working, because I wasn't sure about academia versus industry. I worked at a research center. I worked at General Electric's research center up in the Northeast, upstate New York. And so still heavily research focused. And then I moved from there to back to San Diego, and worked at a company called Cymer, C-Y-M-E-R, Cymer, researching light sources, laser light sources. And we were procured by ASML, and so and I gradually moved within the company more from a research role into a program management role today. So that's sort of been my trajectory over the last 20 or so years, and so I'm happy to take questions or that you might have about how you go down those sorts of paths. So.
Well, thank you very much, Wayne. I'd also like to introduce Professor Massimiliano DeVentra, or Max DeVentra as we call him, who is a professor here at UCSD in physics. And Max, we're just talking about our paths, how we got to where we are today, and in particular with the intersections with industry. So yeah, if you'd like to just introduce yourself and work you down and
well,
your connection.
Thank you. Thank you very much, Adam. I apologize I came late because I gave actually a seminar to our grad students in physics. So I'm a theoretical physicist. I'm a colleague with in the same department as Adam. And so as a postdoc, I actually was a visiting scientist to IBM TJ Watson in New York. And so I had my first experience with the industry, and the IBM actually was an interesting place. Unfortunately, I came at a time when they were about to, go down in terms of research. But it was more like a university center where you could do a lot of research. And so since again the research was kind of winding down, I decided to move to academia. And then, about 10 years ago, out of by accident, I found a paper on how amoebas learn, patterns of temperature. And so I started to think about how to actually do this. So I thought that memory would be the key to this. And I started to work on how to use memory, time, and locality to solve the tough problems. So to actually do solve combinatorial optimization problems. So little by little, we started to to see that we could actually solve a very tough problems very efficiently using a physics-based approach, using time and locality rather than algorithmic approaches. And this led us to write a patent on what we call self-organizing logic gates, which was actually granted. And at the same time, we gave it a pitch. This was 2015, 2016, I believe, something like that. The university just started a program. UC San Diego started a program where they brought on board entrepreneurs. They call them entrepreneurs in residence. 4 or 5 entrepreneurs that would actually help professors, even students to set up companies if they have some ideas. So I gave a pitch in front of John Bean, who's now the CEO of my company, the company we co-founded. He was intrigued by the idea of using a physics-based approach, which is non-quantum, by the way, non-quantum computing, to solve very complex problems. And so we co-founded the company with also a postdoc who's now the CTO of the company, and the 3 of us. We started with nothing, and little by little, we succeeding in getting more funding. Now the company has raised a substantial amount of money. I think we have now 6 or 7 employees, plus some contractors from out of state. And the thing is that the company, which is called MEM Computing Incorporated, MEM stands for memory. Since it's not quantum computing, we could actually start by doing software. So we simulate these machines. Of course, we're thinking about building them in hardware, but the first thing we did was simulating these machines. And already by simulating them, literally by solving differential equations on a laptop, we could actually beat standard algorithms significantly. So the company just released the software as a service, where you can actually solve tough problems, and there are other companies that use it. They're actually using the software as a service, and if you go on the webpage of the company, memcpu.com, you will see many examples of companies that have been using our software as a service. So the path was totally unexpected. I never thought to co-found a company, and I never thought of being advisor and on the board of a company. But actually, it's been a very useful experience also for me as a faculty member, because I see also the other side, right? So I can see how people work in companies, in this case a startup. IBM was more established, so I wouldn't call it a startup, but this one is a startup. And so you see the challenges, but also the rewards of working in a startup. And I find the people that work there, very enthusiastic, very motivated, excellent, people. Their background is varied. My CTO, the CTO is of course a physicist, but we have also computer scientists. We have other physicists, engineers, and so forth. So yeah, it's been an interesting path, non-traditional, I would say, right? But if somebody's interested, we can discuss more. If you have questions about also some difficulties of how to get funding in startups and so forth, we can discuss this. I don't know what else to say other than, follow your path if you're interested. Academia is not the only path, right? So it's fantastic, and I have no regret, in fact, in working in academia, but I see now also the other side, and people are actually enjoying what they're doing. So smart people working on very interesting problems. And so yeah, ask me any question if you have any question. Thank you.
All right, thanks very much, Max. Appreciate that. And by the way, I jumped into this. I was so excited to hear from both of you that I forgot to mention that my name is Professor Adam Burgasser. I'm also in physics, and I'll just be playing host today. And I appreciate everyone for being here today. Now, we had a few questions that were submitted in early, so I'm going to go ahead and start with those. And then a little bit, I would say in about 10, 15 minutes, we'll just open the floor to anyone who has questions here. The first question, I'm going to go ahead and post this into the chat window, was what factors would you recommend graduate students to consider as they think about their career after graduation? I think this is, maybe perhaps particularly tuned to the idea if you're thinking of a path in industry, what factors, what aspects, what training should you consider as a graduate student? So Wayne, I'll let you go ahead and start first on this one.
Sure, thanks, Adam. I think the number one factor that comes to mind in that question, is a great question, by the way, is internships. I mean, they're amazing that you can get to try a company experience without getting basically hired as a full-time employee. And so internships give you the opportunity to see the culture, the company culture, and get a feel for what the difference is between academia and industry. So I'd highly encourage people to do internships in their summer breaks while in graduate school.
Yeah, I second completely this. In fact, we had some interns at our startup as well. So I strongly encourage you to do that if you have a chance. Yeah.
And can I ask both of you, how do students find internships? How do they locate them to get involved?
It's a very good question.
As many emails as possible, or try to contact as many people as possible.
Exactly it. Be persistent.
That's right.
Everyone's busy. Exactly. It's often being persistent also projects a sign of character, right? That, hey, this person is really determined to get here. So persistence pays off. Find people, email people, meet people at, like IEEE events, I think are a good way to meet people from different companies, form a network. It's really, really powerful at getting inside a company, and getting an internship is one thing. Getting someone who can mentor you inside the company. So if you get an internship with wherever, Google or ASML, anywhere, try and seek out a mentor, someone that's going to guide you through that internship. Because even when you finish your internship and you go back to your studies, you've got someone who has an interest in you and keeping a connection with you, and that can really help getting a job afterwards and progressing your career through the company.
Sorry, can I just add one thing for all of the audience here as well? Obviously, attending these kinds of events puts you in a really good position to meet people, to meet people like the speakers that we have today and the speakers that we're going to have in the coming weeks. And as much as you can, get engaged to these sessions, ask questions, and make an impression, that's how you start networking and developing relationships. So all of the events that CNIE and the DS Center and CAP put together for you guys are the sole reason why these companies keep coming back to campus to meet you. And then also very quickly just saying that next Tuesday at 12 p.m. I sent you all guys an email. I'll be speaking about everything related to getting internships for full-time positions through all of our partner companies. So you should have that in your email.
Gracias. Okay, so just a second question, and this is maybe one that maybe Max, you can start off with, and it was, how do you feel? So this is probably the comparison of academic versus industry. How do you feel about the tenure track system?
That's a good question. Well, I mean, again, there is no general answer, right? It's tough, of course, to do a tenure track, right? In the sense that you have to dedicate, 5-6 years with the possibility that it doesn't work out at the end. I mean, it's up to you, literally. Some people say, so one of the things I would like to say, which may actually dispel some myths, is that it is true that probably is if you don't go the academic path, you may make at the beginning somewhat higher salary compared to a tenure track, but it's not what we expect. So it's not that you get into a job immediately after a PhD at $200,000, $300,000 like that out of the blue, as some unfortunately seem to think, right? So the two paths have different rewards, and it depends really on what you want to do. The advantage, of course, of academia is that once you have the tenure, you have a freedom that most likely you don't have in industry, where you have to literally be more into, let's say, into a production type of mode where you deliver on a regular basis. In academia, of course, you have to do also you have to produce papers and so forth, but we have a freedom to choose topics more generally, right? That in industry, you don't. For example, I can give you the example of my company. Of course, if you have a deadline and you have to produce a certain outcome, you have to do it, right? There's no other choice. In academia, literally, I can say, okay, I want to work on this new topic, and literally, there's no one who can tell me no, right? The two paths are different. If you think about going to tenure track, don't be afraid, even if that doesn't go well, because you can always go back to industry, right? I've seen less the other way around, going into industry and then doing a tenure track. I've seen it more in engineering than in physics, but it's not impossible. I would say that it's easier the other way around. So if you do a tenure track and then you realize along the way that it's not for you, you can jump back into the industry sector. But the other way around seems more difficult. So in terms of how I feel in terms of the system itself, that's a tough thing, because there is no perfect system, right? It's like for our papers. Is the referee system perfect? No, right? But we don't have a better a better way, or at least we don't know how to better solve this problem. So it's a long, and I can go on and on this. But again, in terms of you guys, the young guys that want to choose, really think what you want to do. And if you want to spend, more time in an academic environment and so forth, I would suggest go and do a tenure track. If, however, you think you are better off in an industrial setting, then yeah, don't even bother doing a tenure track. You're better off going directly into the industrial setting. I hope I answered your question.
Thanks, Max. And Wayne, do you have any thoughts about that?
Yeah, I mean, Max's points were great. I mean, I agree with Max. I wouldn't pick tenure track as, hey, I want tenure track as the number one thing. I'd think of, where's your passion, where's your energy, right? When you come out of your PhD, you'll be working for a long time. So you really want to find something that gives you energy every day. You wake up, you're like, hey, and so, everybody's different. So try out both, right? Talk to professors on tenure track, and you can find the pros and some of the hurdles. Go do internships. You can talk to people in industry. For me, there is a common thread between academia and at least the industry. I think we would all go in, which is the ability to do deep thinking. So I think in academia, definitely, right, it's all about doing deep thinking on a topic and coming through. In industry, one of the cons you could think of is you can get caught up in emails and presentations and PowerPoints and all this other stuff all day. But, particularly at our company too, it's really highly regarded that people do deep thought and think about problems, more than just doing emails and running around the place sort of thing. So there are some commonalities between the two. So I don't want to give the impression that they're completely orthogonal sort of thing.
Yeah, in the past, sorry to interrupt you. In the past, we used to have these big companies like IBM and Bell Labs that could combine the best of the two worlds, right? So you did research, but you were in an industrial setting with the advantage of having an industry salary, right? Unfortunately, we don't have that much. Maybe big companies like Google, right, or Facebook may have some aspects of that, but I don't think it's as it was in Bell Labs and IBM in the old days.
For sure, Max. Yeah.
Thanks, guys. And actually kind of related to something you just said, Max, in this last answer, there was a question that came in. So we just had a grad talk last week about academic careers, and we had a postdoc who's involved in that discussion, and kept saying, well, if it doesn't work out in academia, you're going to be loved in industry. So you kind of said the same thing just then. So I wanted to kind of dig into that. For those of us who are on this discussion where we're getting advanced degrees in physics and engineering, physical sciences, is that really true? Is it very easy?
I tend to agree with that in the sense that engineers, physicists, mathematicians, and so forth, are in high demand precisely because we are trained to think, right, and solve problems by breaking them down into small pieces and solve those pieces one at a time. So I see this in the sense that I wouldn't be worried if you try a tenure track, then it doesn't work and you want to move back to industry. We are in some sense, trained really well for industry, and so I tend to agree with this assessment. I don't know, Wayne, maybe you have a different point of view.
Thanks, Max. Yeah, I think you're right. I mean, I think of when I review resumes and things of people, if they've been on a tenure track and then they're applying to come into industry, I certainly don't see it as a negative sort of thing. It's like, well, what did you do? What problems did you solve? Because as Max said, it's all about that, breaking down problems. So it's I think, you do have the opportunity to move from tenure track into industry at different points. You don't have to force it at the end of your PhD.
Right.
All right, thank you. So we're going to switch now to questions from the audience, and Alicia has actually already posted one. So Alicia, I'm going to, let's see, I think you should be able to unmute yourself, but if you can't, just text me. There we go. Yep.
Yep. Hi, hi, Wayne.
Hi, Alicia.
Just had a question for you. So I was wondering, if you work in industry, does it tend, I mean, you're a project manager now, so do you miss the research?
That's a good question, Alicia. By the way, Alicia and I used to work together a long time ago, so we know each other. Do I miss the research? So I will say this, I purposely did look for a company that does have a high level of technical complexity sort of thing. So in order to fulfill that piece of wanting to do research, I mean, everyone doing higher degrees, there's some passion in you that wants to do research, and so if you went to a company, if as a physicist, for example, you went to a company that maybe builds bridges that are fairly standard engineering type things, not to offend bridge makers out there, but there's not a huge amount of innovation as far as I can see, then you might it might get into a fairly regular sort of exercise that, I'm just doing the same thing over and over. If you pick a company that's pioneering research, Google, like Max said, at ASML, we're definitely pioneering research and pushing the edges of physics. So by being involved in that, then in my day-to-day, part of it is setting schedules and making sure resources are there and that. Another part of it is, how do I stop 30 micron molten tin droplets from breaking up under a flow of hydrogen in while 100 kilowatt lasers hitting it? There's enough physics and excitement in there that it allows me to basically do the deep thought on technical stuff. So that's how I get my fix of the deep technical on the research side. But it's a good question, Alicia. Thank you.
Thanks, Wayne.
Okay, any other questions from the audience? And if you can, please use the raise hand feature that's in the reactions section.
Can I ask a question for Wayne?
Oh, sure. Yeah, go ahead.
Hello, Wayne. My name is Zhao Xian.
Hi, Zazin.
You said that you weren't a researcher in ASML before, and then you move into the program management position.
Mm-hmm.
So my question then is, what difference do you think are there between like industry research and academia research?
Okay, good question. So what, let me see if I capture it right. So I was in research, I moved into program. And you're saying, what difference do I see between industry research and academia research?
Yeah, because you were doing like research in industry and academia, like in both areas. So what is the difference between them?
Great question. I think Max had said it a bit earlier too. So in industry, there's definitely a time dimension, right? We release a product every 2 years. And that's not negotiable, right? The product has to release, and our ambition for the products tend to be very high, right? It's what our customers want. And so in doing the research, we have to bring in a level of pragmatism pretty quickly. So if I think back to my PhD, the analyzing the problem, it expanded, and I could go and explore this area over here and this area and do all sorts of different things, because there wasn't that time boundary. In industry, it's like, okay, we could go explore 3 areas. Due to time, we've got to pick one. Which one do we want? Let's do this one. And so we go after that one. If it works, we keep going. If it fails, then we might go to a different one. So time is always there. But I, as someone who comes from sort of a research background, I also try to enable the researchers we have to be able to explore and get the best solution. So you'll find people in industry who are always just like against the clock. Okay, I need this yesterday. I need this. They'll tend to be more extroverted. And I have to remind them that it's the introverted people who are going to solve the problem. The extroverted people talk about it, while the introverted people are actually doing it. And so I spend a fair bit of my time providing, running interference so that the introverted people have enough time to solve the problems and come up with really, really good solutions, which they do. I just got to hold back the rest of the organization that's watching the clock.
Max, do you have any comments on this?
Yeah, no, I was about to say something. In fact, pick, for example, MEM computing, right, which is this new computing paradigm we came up with. Well, in the company, as Wayne was saying, we have deadlines. We have to produce, for example, the SaaS, right, and it has to work for customers, right? So you have people that pay, and so they want this by yesterday sometimes, right? Like Wayne was saying. In academia, I mean, so that I would call it more, research and development, right? In our case, I can literally sit and say, well, but what does it make it so powerful, right? And say, oh, but look, actually, I can use techniques of quantum field theory to understand that, why it is so powerful, which allows us to spend a year maybe on something that will not even pan out, right, at the end. So the time, as Wayne was saying, is indeed the key, I think. In academia, you have less time constraint. You don't have customers that are behind you. Of course, also in academia, as you know, Adam, right? We have to produce papers. We get evaluated every 3 years and so forth. But I would say it's a different type of the pressure than in industry.
Definitely, yeah.
I would definitely agree. Yeah. Other questions?
Yeah, thank you, Wayne. Thank you, Max.
Mhm.
Thank you. That's it.
Nancy?
Hi, you guys spoke about the path to transition if you are on this tenure track path from there into industry. I was wondering about the other way around and what kinds of things maybe one should seek to learn while you're in industry in order to be better suited or to you know, improve your chances in if you were switching back into the academic track.
Yeah, I can say that I know very few cases of people transitioning from industry to academia. Typically, these people have worked in industry mostly in research and development, so they could actually publish. And remember that when you apply for an academic job, the first thing we look for are publications and the impact of those publications. So the people I know of that actually transitioned from industry to academia, they published, and their publications were impactful. So they were cited and they were known in their respective field. I know that I don't know people that actually transition into tenure track, but generally these people transition into either associate professor or full professor with tenure, or an accelerated type of tenure track, like in certain university you can do it in a year or two, right? So this is the type of people that I know of that actually did, and there are very few, at least the ones I know. Again, because the requirements in academia are you have to publish, you have to have your papers, cited, you have to show that you're known in the field that you're working on, which is not necessarily the same thing as what we require in industry, right? In fact, in my company, they rarely publish, right? They do publish, but not as much as we do. Does it answer your question?
Yes, I guess I'll just add really quickly. What about if you're on like a shorter timeline? So I don't mean like you've spent 10 years in industry and all of a sudden you want to go back and be a professor, but what about those students that spend maybe a year or two in industry and then go into...
That may be seen again less problematic, okay. But again, you have to pay attention to publications, I would say, because again, one way of getting a job in academia is you have to show publications and impact of the work you do. You see what I'm saying? On top of the fact that you have to have letters of recommendation from people in academia, most likely to actually help you get a job, right? Now, again, the cases I know of are in engineering, so maybe in engineering is different than in the physical sciences. In fact, I don't know, maybe Adam knows, but I don't know of anybody in the physical sciences that actually went to industry, even for a short period of time, then transitioned to academia. And I'm not considering those that actually were at Bell Labs or IBM, because Bell Labs and IBM, remember at the peak of their fame, were essentially universities with no teaching. So they had the fantastic researchers, Nobel Prize winners, and so forth. So those people could easily transition into academia, but because IBM and Bell Labs in those times were essentially, better than Harvard or MIT. You see what I'm saying? But I'm talking about now, right? So people that actually try to transition from an industry to academia, unless you have, again, impact publications and maybe collaborations with people in academia and so forth, I would say it's not an easy thing to do. Maybe Wayne knows better, I don't know.
Well, Nancy, I'll point out that, so last week we had Chris Tyson, a postdoc who was speaking, and he actually went into industry for a year. And that's, it's a short time, as you were sort of asking about. And, within a year, there's not much, changed. Yeah. You still have the same, letter writers, right. Your publications are still relatively fresh. So, right. If you're thinking, maybe I should consider trying industry for a year, I think particularly if you're fresh off your PhD, you've just gotten a whole load of publications out there. There's a little risk of not or sort of capitalizing on that research coming out because you may not have as much time. But I think that time scale is relatively safe. It's really
it could be seen as a postdoc, in fact, right? So yeah, I totally agree with you. If it is longer than that, I think you risk, if you don't have publications, you keep contact with academia, at least working with people in academia. But if it is a year, yeah, I mean, it could still work.
Yep.
Okay, thank you.
Yeah, thanks for the question. Mel, I see you have your hand up. You have a question?
Hey, hi, Jess, thank you. So I was wondering that since you both since you have been at both sides, what do you think about the collaboration between academy and industry? It always feels like you have to take one side, and like, since you have been there, like, what things do you think that should improve in terms of collaboration between both of them?
Yeah, I don't know if Wayne, can I go first?
Yeah, go for it.
Yeah, so one of the, I mean, collaborations are great. The only issue, it may depend on the university, are patents. So remember that if you work with the industry, right, and you produce something that is useful, then patents come out. And then the university, wants to have a share in those patents, and sometimes they actually want the whole thing, the whole pie, rather than because they say, well, we actually give you a professor, for example, that works on this, or a postdoc or a student, right? So we want to have a maybe not 100%, but a large chunk. So that could create an issue in practical terms. The best course of actions I've seen is that the industry says, okay, I'll give the professor a certain amount of money to pay a PhD student or a postdoc, and that allows us to publish together without much worrying about, publications. I've done this, for example, with the Lockheed Martin, patents. I've done this with the Lockheed Martin in the past. But for example, it didn't work with a major company because UCSD wanted the whole thing. The company wanted to split the patents, and UCSD said no. And so the company didn't give me the funds. So it is both ways, right? So it depends on the situation, depends on the university. I suspect that some universities are more open than others, so they have a better structure for the collaborations between industry and academia. Remember that anything that Adam and I do, right, or create, even anything, and we try to patent, it's owned by the university. The university owns the whole thing. So putting that, if you have a collaboration with industry, you have to negotiate who gets what, right? So that's my experience. I don't know, Wayne, if you have other things to add.
Yeah, Max, it's a great question. I think you hit the nail on the head with the patent side. There ends up being a wrestling match at times over patents. I think where it's funny because it's a fairly symbiotic relationship, right? Having the industry needs the university to go out there and do this pioneering research and look at all different things. I mean, if you look at the product that we sell, its roots are from university research, and so. But then the university research piece is not enough for it to be a product. Someone has to take it from that research phase into a product, and it tends to be a tremendous amount of work. And so each party tends to want to be rewarded. But I like Max's approach, which is by the industry. Industry tends to have the money, sort of thing. It's getting the money from the product to give money to professors and get just research going and not constrain them too much. That tends to be what industry tries to do, is say, hey, I need a solution to this and I need it next week. Let academia do its thing and come up with just ideas and potential solutions, and then industry latch onto that. So, but it tends to be that interface, and it tends to manifest as as patents and who owns the IP and that sort of thing. So, but in most cases, I think in my history, we've been able to negotiate a middle ground sort of thing. Okay, we'll patent this bit, company will own that, academia, you know, you'll keep this, you'll publish it freely, or you'll patent it, or so. But it is part of the equation in that relationship.
All right, thanks for the question, Mel.
Great question.
So we have about 5 more minutes. Are there any other questions for Wayne or Max? Jacob?
Hi guys. One question I had is, like, looking back, what would you say would be one skill that you would like to have developed in grad school after you had gone to the industry?
I think for me personally, I found in grad school, there can be the tendency, or speak from my own histories, you know, there's graduate students researching different things, right? And I found my research was essentially my own, right? I'm doing, you know, independent thought. And then from time to time, there'd be, you know, you'd partner up with someone from a different university for something, and then you'd go back to your independent thinking. In industry, it's all team. It's all team based. I mean, you can't get, the bigger the company, the less you can get done by yourself. It really is how you can build relationships and interact with people and stuff. And so I think making sure you keep that going, right? Because 4 or 5 years, 6 years, whatever, a PhD is quite a long time. And if you get into purely silo-based thinking, then if you go into industry, then that's one of the first things they need to sort of relax a bit on you is hey, you know, there's other people here and they want to help you and they want to work together with you on the problem. So it's maybe one reflection I had on the transition.
Yeah, I would add to that actually. I wish I learned more also how to discuss complex ideas in simple terms that people could actually, with different backgrounds, could actually understand. That, I think, it's a skill that is very important, because when you go to industry, you're going to have physicists, an engineer, computer scientists, people from totally different backgrounds. It's good to know how to present ideas and how to, you know, make them clear to a broader audience. This is true also in academia, of course, right? To present our work. But I think in industry, I've seen this to be even more important, and maybe Wayne can jump in on this.
Yeah, that's a really, really good one, Max. And this one, in academia, I find, right, it's about how much technical depth can you go into on a topic, right? And you'll get challenged. Do you really know? And I see it, right? It's almost like a form of honesty. If you really know what you're talking about, then it's really yours and you really did it. And so that's very important. In industry, it's about getting a message across as succinctly as possible. And it's really a skill. And I'll tell you, an experience for me was in one of my leadership trainings, they took a bunch of us, and we're all engineer, physicist type backgrounds, and they paired us up with actors, Hollywood actors. It was an expensive leadership course, and we were to tell a story to the actors, and you know, you could see people, and we developed amazing stuff. Each individual had done amazing work, but when they tell the story in A, B, C, D, and they're just explaining it all in historical terms, the actor was just like, "This is the most boring story I've ever heard, and you've lost me. I don't understand what you're saying." And it really made me think, if you look at the way movies are put together in scenes, and a scene tells you something, it has a purpose, makes you feel some emotion, and it together tells a story. That is how humans take in information. And so if you're trying to convey something to someone, Hollywood actually has it quite right? They have the equation that humans like. And so the one thing you'll hear in industry a lot, if you're telling a complex story and it's just dragging on and you're losing people, and that thing I've heard a lot is try explaining it to your spouse or your next door neighbor, right? This exact thing that you're working on. Go to your next door neighbor who has nothing to do with this industry and explain it to them what you're doing. And try it. It is real. You're trying to explain to a layman what you're doing to get the message across rather than impress them with all the technical detail that you know. And so that is man, if you can hone that skill from an early age, that is how you'll resonate with people. That's how you'll find a mentor more easy. That's everything. All these doors will just open because you're able to communicate simply in a way that resonates with the person you're talking to.
Yeah, I'll just jump in that, it is a skill, and we had a growth mindset workshop last quarter, and it's a skill that can be learned. And when I was at a postdoc at the American Museum of Natural History, I used to work side by side with Neil deGrasse Tyson, and he told me that he practiced for years on how to distill complex scientific, results to 5 words, right? And you could say that's a little bit too little, but he developed that skill. And I think Max is right, is that this is a skill that's important not just for industry but for academia as well.
Yes.
Yeah.
Yes.
Very good question.
Okay, so we're at 12:50. So unless there's any last minute burning questions, I'd like to take a moment to thank both Wayne and Max for taking their time out today to share their experience and their wisdom about industry careers. And I'd like to thank all of you for taking your lunch time out to learn a little bit more about that path and ask your questions. And just a reminder that we have 8 more weeks of Grad Talks this quarter. So if you want to learn more, please go to the website and see what's coming up. And thank you all for attending today. And thank you for Sinai and Rossio for organizing.
Thank you very much.